Thanks once again for joining. This is our second class. In the last class, what I have tried to do to give an outline of the development, early development of quantum theory, quantum concepts, not quantum mechanics as such, but the theories and concepts. The basic experimental facts that could not be explained by the existing classical science, classical mechanics. Mainly three experiments, three such, and how people came forward with their innovative, noble ideas to explain all those facts, maybe with some very new, revolutionary ideas, and which defied the common sense very much. And initially, people were not ready to believe all those concepts, but later on, they were forced to believe that okay, this is the only way to explain how nature works. So it happened like that, and as a result, we got quantum mechanics and quantum theories initially, and then quantum mechanics, right? And so much so that not only that people didn't believe. Sometimes it happened so that the person who is responsible for that discovery, he himself didn't believe that much. That also happened for the first time in history of science. For example, Max Planck, he himself didn't believe. He was not ready to believe till his last breath. Similarly, Einstein, to some extent, he couldn't accept the concepts which initially he proposed, and later on people followed Einstein and proposed and extended further, but finally Einstein didn't believe those extrapolation. So that happened a number of times in the science of quantum development. The facts and the basic science and concept that we have discussed in the last class. So today I have promised you, as I have promised you, that we will discuss a few more interesting facts, and moreover the debate that happened between great minds as far as the interpretation and explanation, in short, as far as the philosophy of the subject is concerned. Where someone is joining, just a minute. So as far as the philosophy of the subject is concerned, we witnessed that there are a lot of debates. Okay. In fact, there are two school of thoughts. One is led by Einstein. Planck partly belonged to that group, and the other one was led by Niels Bohr, and the followers were many more in number in the Bohr's group. Anyway, that is a separate story. Today I'll be discussing some of the basic thoughts behind the thoughts of the great men, right? How could they think in that way, and if there is any debate at all, what is the source of that debate? It's a philosophical debate, more or less. No debate was there actually regarding the science of quantum mechanics. Okay, that I repeatedly I am telling you. Well, as far as today's lecture is concerned, again let me start with the references. A few different types of books. I will show you the first page of the books. The first two, Einstein, a centenary volume, and Niels Bohr, a centenary volume. These books are really rare. They are not easily available in the market, but that describes a lot, many words between the words, so many anecdotes, so much of different type of writings. These two books. Then Galileo's Finger, and I mentioned in the last class 30 years that took the George Gamow book. And this is very interesting book. Einstein's Miraculous Year. I mentioned in the last class that in the same year 1905 he published actually 5 papers. So today we will see what are those 5 papers, at least the title of those papers. And I also mentioned that any one of those 5 papers might have bought him the Nobel Prize, as people believe. But finally he got it for the photoelectric effect paper. And then the quantum and the lotus is another different kind of book that I will mention. And then a few important quotation I have used in today's class that I have taken from the new quotable Einstein book. So my quotations are reliable, that's why I am showing you the reference. Okay, and now this is the first page of the book Einstein, a centenary volume. I do have those books, I have got it from abroad. And this is another same type of same series book, Niels Bohr, a centenary volume. And then this is that interesting book, that Einstein's miraculous year, 5 papers that changed the face of physics. And this is the book that I was referring, George Gamow, 30 years that shook physics, the story of quantum theory. Well, George Gamow spelling is okay, not double M, but single M is there. And then the Peter Atkins. Atkins is one of my favorite authors, physical chemistry textbooks, quantum mechanics textbooks, spectroscopy, and many other books he has written actually. This is one of the interesting books written by that same Peter Atkins, who has written the physical chemistry textbook. And this is a separate, altogether a separate kind of book. You see, a journey to the frontiers where science and Buddhism meet. So they are talking about very old Eastern philosophy, Buddhist philosophy, and quantum science, and how the two different branches of human intellect are merging in the frontiers. So the name is the quantum of the and the lotus. This Matthew Ricard is one of the actually he is a scientist, neuroscientist. He was working as a PhD postdoc scholar, and then all on a sudden he thought that okay, this is not my cup of tea, and overnight he left the laboratory and went for Nepal. Later on he became a famous Buddhist monk. And another is physicist. So it's a dialogue between a neuroscientist turned Buddhist monk and a physicist. Okay, so this is a very interesting read. And then a quotable Einstein. So these are the few references I have used for my lecture. Let me start with a little bit of history of science, not particularly quantum. 5 paradigm shifts in the total history of science. If you just split the total development in 5 compartments, then you can think of these 5 paradigm shifts, revolutionary shifts. The first one is acknowledged as the ancient Greek and Euclidean geometry, and they were talking about rigid body and static configuration. So this paradigm shift happened mainly due to the mathematical reasoning first time came into the picture in our insights and into nature. So mathematical reasoning made the first shift to occur. And the second one, 17th century, Galileo and Newton. So from static and rigid body, now they are moving to the motion, force, acceleration, all this, Newton's laws. So they are talking about motion. So we have a shift from static to dynamic. Choroi beti, go ahead. And then comes the 19th century, Faraday and Maxwell. So they are talking about wave or oscillation, and they're talking about continuous field, EMR, electromagnetic radiation, light. So they were now starting to explain this kind of light concepts involving wave or oscillation. Beginning of modern science, you can say, when we got a shift, a switch over from deductive to inductive science, and tomar holo shuru, amar holo shara, perfect line for this picture, pair of pictures. This man, you notice the year 1564 and 1642, birth and death. So 1642 someone is passing away, and in 1643 you just see 1642 1643. So enar shara holo or enar shuru holo. So can you guess these two figures? One is quite visible on the left hand side. What about the right hand side figure?
Newton or Galileo?
Well explained, well said. So Galileo or Newton, tomar holo shuru, amar holo shara. That's very interesting. Now we have narrated the first three paradigm shifts. Now I am talking about the fourth and fifth, and very interestingly, two of the major shifts, in the history of science, was done by a single man in 1905. Just a single man. Both the paradigm shifts came from his brain, his thought. Can you again guess this person? 1905. This year is otherwise very important.
Einstein.
আইনস্টাইন 1905 বঙ্গভঙ্গ আন্দোলন হয়েছিল আর 1905 আইনস্টাইনের 5টা পেপার বেরিয়েছিল, right? This is Einstein. So let me come one by one. The fourth paradigm shift or revolutionary thought, it changed space and time into space hyphen time. So it was different concepts. One of space, another was time. But first time, space-time got coupled, right? Space hyphen time. That is actually relativity. The concept space and time, they lost their absolute independent separate notion. Now they are coupled. So that is the fourth revolution through relativity. And of course the fifth revolution is talking about the quantum theory. Matter, radiation, wave particle duality, probabilistic nature. So some very new, apparently unbelievable concepts were introduced through the fifth revolution period, and so much so that they defied common sense, and the whole concept of reality that has been changed after the quantum revolution. For example, reality subject to observer. Reality is reality. Whether you observe it or not, it doesn't depend. It should not depend according to the classical science. But when it comes to quantum, because of some uncertainty principle, the subject it is subjected to the presence of the observer. So আমার চেতনার রঙে রাঙা হলো চুনি, পান্না হলো সবুজ. So chetona becoming important in a very scientific way. There was no question of uncertainty in classical science, but in quantum, uncertainty is there, and the reality lost its determinism, right? So these are the few things revolutionary came from this person, Albert Einstein. So very quickly, just let us have a look all those 5 papers. As information, these are very important because we know about only one paper, that photoelectric effect, and at best another one, relativity. But these were the 5 papers. The first one is from Einstein's dissertation, a new determination of molecular dimensions. And the second one, can you believe that it is on Brownian motion, right? It's a bit biology and physics. As a statistical understanding. So biology was there, mathematics was there, and physics was there. Excuse me. And Pandits say they believe that this paper on Brownian motion, it itself could have earned him a place in the history before, even without these two. So that's so important. And the third and fourth papers both were on relativity, special relativity, of course, because general relativity papers were published in 1913. So in 1905, 2 papers on relativity. Absolute time, the concept absolute time is lost. It is now we have to associate with space as well, and a very famous formula, very simple looking formula, E equal to mc square, was given by this paper. And finally, the photoelectric effect paper. The concept of photon, we got light as photon particles, though the name photon was given much later by someone in 1921, but the concept was given in 1905. And according to Einstein himself, out of these 5, this is the most revolutionary. You see, Einstein is not referring the relativity papers as the most revolutionary, but to him this paper is most revolutionary, and anyway he got Nobel Prize for this revolutionary paper or idea. So we see that Einstein as a founding leader and pioneer of quantum theory. Okay, fine. Okay, can you hear me? Can you hear me?
Yes, sir.
Okay.
Yes.
Okay. Thank you. Now, yesterday I picked up 9 heroes of quantum world, and today I will just narrate almost the same thing but in a different style. This is a kind of fairy tale kind of thing. Alice in Wonderland is a fairy tale story, all time famous, and like that in Bengali we have a few books. A story of Aladdin, Aladdin o Aschorjo Pradip, right? Aladdin and Aschorjo Pradip. Another is Saat Bhai Champa, so Thakumar Jhuli, etc., etc. So I have compiled all these headings together. This quantum is like a Champa of 7 brothers, Saat Bhai Champa, quantum. Or you can say that the title goes like a story of Aladdin's magic chair, not magic lamp. I have changed the title a little bit. It's a story of magic chair, Kedara chair, or you can say story of magic chair in Wonderland, Alice's Wonderland. So in a bit lighter note, I have compiled the headings of taken from different fairy tales, and the 7 brothers, I will tell you what the names of the 7 brothers, and this is the magic chair. Okay, so I will try to show you that how this magic chair, like the magic lamp of Aladdin, it connected all these 7 brothers in the single thread to give a story of Saat Bhai Champa. Okay, my drawing is not that good, but would you acknowledge that it looks like a chair to some extent? Would you acknowledge that it is?
Yes, sir. It's quite
It looks.
evident that it's a chair.
It's a chair. Okay. What kind of
Yeah.
chair? Can you guess? What kind of chair is made of what? What are the attributes of this? What kind of chair it is? Any
Sir, wooden chair.
wooden chair. Not iron chair. Not iron chair. Wooden. Okay.
Maybe. I don't know.
Maybe. Okay. The hands, the hatals are not there. The hands of the chair. Is it missing or it is hidden? Okay, I will not keep you in dark for long. Let me give you the story of 7 brothers and this musical chair, magical and musical both. So, are you interested to listen to a story only in a quantum class?
Yes, sir.
Yes, sir. Okay. Actually, after a few minutes, we will reveal that it's not really a story, neither it's a chair. Okay, let me go ahead. Max Planck, the first brother, Max Planck, Krishna Koli Amitare Boli, the famous Tagore song, Krishna Koli Amitare Boli. Krishna Koli is the black body, right? Black body, Krishna Koli. To Max Planck, black body was the Krishna Koli, and the expression, his famous historical expression he introduced, that E equal to H nu. So I think now you have got it. My point that the chair is not actually the chair, but it is the what? It is the what? It looks like a chair, but in the expression the chair is there, isn't it? Can you find? Can you see H? So it is the Planck constant. Okay. The first time we got a constant called Planck constant in 1900. Actually, it came in October, and to be precise, in December 1900. So, what I gather here, that all the story of all the 7 brothers, in each of the story of 7 brothers, it is the chair is there, the Planck constant is there. That's why the story goes like that. So, the first chair you have got in the expression E equal to H nu, right? And then came Einstein, as I have discussed in the last class. Again, the chair is there, and the equation is again the same, E equal to nh nu. That gave the concept of light particles. Well, the third brother, Niels Bohr. Again, the H is there. Angular momentum is nh by 2 pi. So you see the red, the color of the chair is red in all the expressions, red, nh by 2 pi. So that is the Bohr, my third brother in my story of 7 brothers and Champa. De Broglie. De Broglie, again H is there, P equals to H by lambda. So that was his PhD thesis actually, as I mentioned in the last class. And then comes Schrodinger. Initially, you may be surprised that in Schrodinger's equation, H cycle to E cycle, this H is capital H, this is not the small h. So this should not be there in your list, but no, it is there, because H is the Hamiltonian, the kinetic and potential, the total energy operator. And in the total energy operator, in the kinetic part, it is actually minus h bar square by 2m, and that h is there. So again, the magical chair is there in Schrodinger's story. Heisenberg, again the uncertainty principle, it is h by 4 pi, right? So h cross by 2, h bar by 2, we call it h bar. In the atomic unit, h bar is 1 and h bar is h by 2 pi. So the precisely the uncertainty relation is this: delta x and delta px greater than equal to h bar by 2. You may be confused that in some text they write it h, sometimes you will see h by 2 or h bar by 2. They are very close, but actually the right value is h bar by 2. So why so that though it is actually h bar by 2, but some authors write whatever they like, h bar, h by 2, h bar by 2, because h, the value of h is of the order 10 to the minus 34, right, joule second. So it's such a number that it hardly matters whether you are multiplying by 2 or dividing by 2. So that's why it is not that big error, but error is error after all. So it should be h bar by 2 or h by 4 pi. So that's all about our 6 brothers in South Bhai Champa, 6 brothers. Have you ever noticed in this way that how all the 6 dominating important figures or their science, how interestingly something is common, and that common is that magic chair? Have you ever noticed in this way?
No, sir.
No, sir. Actually, I delivered this lecture long back, maybe 5 or 6 years back in Jadavpur University, in presence of the teachers. So I casually placed this. No. First time I gave it in Presidency College, where the teachers were there and as well as students are there. So I casually placed this South Bhai Champa and Krishna Kuli story, and then some teacher from Presidency College, he stood up and bowed and told, sir, this is, maybe you are talking very casually, but this is very interesting finding that everywhere H is there. Okay, some science must be there behind it, but it is very interesting to note. Anyway, who is my 7th brother in my story, right? So I have deliberately taken the 7th brother as my SNB. Can you give the full form of SNB?
Satyendranath.
Satyendranath Bose.
Very good. Very good. Satyendranath Bose. The common thing is that H is also there, because in his Bose-Einstein statistics, he is famous for SNB, and that's why the particles are named after the name of SNB, bosons. The other kind of particles are fermions, right? But this is common. He has with the other 6 brothers, but at the same time he has a remarkable uncommon something, which is a tragic something, I would say. What is that? Which is not common with the other 6 brothers. SNB is alone over there.
H. No.
No, on what
Presence
aspect?
of H.
উনি বোধহয় ওনার আগে একজন লেকচার দিয়েছিলেন একটা সেমিনারে, উনি তারপরে দিয়েছিলেন, ওনাকে করা হয়েছিল এরকম কিছু একটা।
No. The uncommon thing is the common thing that yes, SNB can be listed in the same list along with these 6 brothers, but the uncommon thing is that all other 6 brothers, they got Nobel prizes except SNB. So that's why it's a tragic. As you know, in every story there is a tragic hero. So SNB in my story is the tragic hero. He didn't receive the Nobel Prize. He didn't get it, but he deserved it. Many people say. Okay, SNB is a different story. In some other day, if I can get the chance, I can elaborate the kahani of SNB or Bheto Bangali. So that's all about my Seven Brothers and Sadbhai Champa's story of quantum. Okay. So in future, if you get the chance, you may narrate this small story of 5 minutes to your younger brothers and sisters. Probably they will like it. Well, in a lighter mode, let me have a googly. Googly, what is a googly? Do you know what googly is referred to? Googly is a delivery, a special kind of delivery in cricket ball, right? Googly. And another googly interpretation is that some of you might have seen the Dadagiri program conducted by none other than our Dada Saurav Ganguly. And in his program, in his episode, each episode, a part of a question and answer was given the name a googly part. So it's nothing but a question, but in a tricky way. The question is placed in a tricky way, maybe in such a trick that the question itself contained the answer, but the participants couldn't find it. Because it was so tricky. So that's a googly. Okay, so I have elaborated a story involving 7 brothers. Now, after that story, I am asking this googly question, that if I were not there, quantum mechanics would have been impossible. If I were not there, quantum mechanics would have been impossible. Supposing that this is a statement from someone, if you suppose in that way, it apparently looks like that it's a statement from some person. अगर मैं नहीं होता तो क्वांटम मैकेनिक्स ही होता नहीं, ऐसे कुछ. So if I am not there, quantum mechanics would have been impossible. But my question is that who can be that person? If it's at all a person, then who can be that person?
Imagination.
Person out of the 7 brothers. I couldn't get you. Out of 7, can you?
Sir, I মানে কি এখানে imaginary number বোঝাচ্ছে?
You have given the right answer actually. Somehow it didn't click.
তার মানে 14, sir.
Actually, I played this game in that lecture, and interestingly, that was the first time actually. Interestingly, the teachers, most of the participants were teachers from different colleges. They responded mentioning some name of their choice as this kind of person that without whom the quantum mechanics would have been impossible. Mostly they told about Einstein, and the second highest vote was of Planck, and then came Niels Bohr, and so different answers came from different people. And as a hint, I told them that the answer may not be unique, but what answer you choose, you have to explain why you are choosing that answer. So now they were trying to explain why their answer is Einstein, why their answer is Bohr, etc., etc. Then a third year student of Presidency College stood up, and he told that, sir, I don't think that I is any person. Is it root over -1? And then I requested the whole house to give a big clap, and that he has got the right answer. So it was full of laughter in the whole class, the teachers and students too jointly. So yes, which figure I is so audacious? The answer is square root of -1. So imaginary number. You know, this number itself is very, very interesting number. It has a very good lengthy science, history. A lot of stories are there, lot of science are there. Of course, mathematics is there, and development of so much of mathematics depends on this number. So altogether, it's a very different story. In fact, for your information, I have a separate lecture on this square root of -1. I have delivered 1 or 2 occasions, but I have not recorded it so far. But I have an intention to record it and publish it in my YouTube channel, because that is going to be a very instructive video, root over -1. Anyway, so thank you for your answer. You have got the right answer, the right moment. Well, if you want to take a break, then I can provide you a drink. How I want a drink, alcoholic of course, after the heavy lectures involving quantum mechanics. So do you feel like that my lecture is too heavy and that's why I need a drink, and but preferably an alcoholic drink? Do you feel like that? that you need a drink. You don't hesitate. You can express you are matured enough. Do you feel like that? That it's so tiring, so boring, so you need a break, or is it okay? You can go ahead. So what's your response?
So if the drink is lightly alcoholic, then the मतलब मजा ज़्यादा आएगा.
Your sound voice was.
It's not boring at all. It's like you will enjoy more.
Well, I can guess your answer, your response. You are not at all bored. I am confident. But still, why I am placing this slide? Because very interesting. This is another puzzle, you can say. If you count the number of letters in each word, okay, how HOW. So 3 letters are there. So take a 3, and then I. So 1, and then 1, 4. So if you, in such a way, if you jot down the numbers, corresponding digits corresponding to the words, then you will get this number actually. So this is a game, and this number, can you identify this number? Of course you can. What this number? Pi.
Pi.
Pi. Pi is another interesting.
Pi.
Yeah. Thank you.
Pi.
Pi. So পাই এত সহজ, কিন্তু অত সহজে পাইনি আমরা পায়ের কনসেপ্ট। পাইকে পেতে হলে অনেক কাঠখড় পোয়াতে হবে, পোয়ানোর কথা ছিল, পুইয়েছে অনেক কিছু লোক, আমরা আজকাল সহজে ব্যবহার করি। and it's a different story again, pi story. And again, for your information, I have a separate lecture on pi itself, only pi. Pi, its discovery, its development, its history, its anecdotes, its application in different branches, particularly in chemistry. In physical chemistry textbooks, if you start counting pi, how many ways, how many places, different places pi has been used, you'll be surprised to know it would be much more than a few hundreds, right? So pi is a very interesting number, and this is somehow I placed it in a very lighter note. So let me go ahead. Dualism that I was talking about, it is a concept that not out of blue, you know, and people got it in dream. It's not that kind of thing. Actually, the concept was prevailing in the nature. For example, duality in different forms, say mechanics and electromagnetic field. Mechanics is talking about some solid object, and field is of course it's not talking about any object. So but they were there as the two sides of the same coin, as if the duality. Similarly, force and field, something localized versus something distributive, particle versus field, and finally, as we see in quantum world, discrete versus continuous. But duality is already there in different concepts, right? So the gap between this mechanics and field, it's talking about the matter and it's talking about the field, and these two different isolated islands, the bridge was not constructed by Maxwell, who was giving the field theory, but actually was given by Einstein. So the black body radiations was re-established by this Einstein concept. Well, let me now switch over to something different aspect. I call it a fundamental why and a why not. So often we ask a question that why this is so, but sometimes we ask why this is not so. So to a few fundamental concepts, actually we can raise both the questions, why it is like that and why not it is otherwise, right? So let me go ahead with a very interesting narration about Einstein's self-contradiction. So you may be surprised that sir, you don't forget that you are going to talk about none other than the big boss Einstein, and you are going to talk that Einstein suffered from self-contradiction. Are you going to talk that? My answer is yes. Self-contradiction of Einstein. Well, I got it from WhatsApp. Though I am very careful regarding using WhatsApp, because you know that there is a concept of existence of WhatsApp University, because the political parties, they use this media as for their own narrow interest. They fake news, very discriminatory news, very demeaning news, etc. They publish through WhatsApp and Facebook. So everyone has to be very careful regarding using, as far as information is concerned, or opinion building is concerned. You have to be very careful. But sometimes really I get very entertaining something, very interesting something. This is one such example. You see, I think you will agree with me that it's a very interesting figure. In Bengali it is written that জাতীয় পুরস্কার প্রাপ্ত দুটো আলাদা মুখ অথচ একটা চোখ একটা অনুভূতি. So two bodies, two fellows, but the same feeling. So it is talking something very great. Why I am referring to this figure, that it will be clear a few minutes later. Well, so now let me explain why I am telling that self-contradiction of Einstein. You know, in paper 3, 1905, and even in paper 5, these two papers, if you consider these two papers in the same year, Einstein is starting his paper of relativity by citing, and which he is actually relying a lot in his paper on this first expression or conception. He is starting with the quotation that accepting that fact that light is electromagnetic wave. So light is electromagnetic wave. That is his starting point of the third paper 3. And in the same year, in paper 5, he is contradicting and saying that light is not wave, but light is particle. So it is completely my perception. I look like this. I would like to look like this as a contradiction. Apparently, to start with, that in the both in the couple of papers in the same year, Einstein, as if contradicting himself, once saying that a light is like this, and in the next paper he is saying light is not like this, it is like that. So this and that, electromagnetic wave versus particle nature. So that is clearly a contradiction. If you agree or not, it is clearly a contradiction. Now I call it that in Buddha's thought, that means if we just rely the philosophical thought or doctrine, there is a very important doctrine or a principle in Buddhist philosophy, which is called the Great Middle Way. The Great Middle Way. It's a kind of thing that it is neither the extreme of this kind nor the other extreme, but it is an emergence of something else, embracing both the two extremes, that emergence to something attributes of each the extremes, but it is something different from both the extremes. That's the middle something. So that is a philosophical thought, but I can connect this philosophical thought with this puzzle, that why and how a man like Einstein was contradicting himself. Right. Later on, I will show that actually he was not contradicting. Well, this great middle way, it's a kind of thing that the first option is either or, and I am saying not either or. That means you better not to go for this option, either or. That means either you are right or I am right. When you are debating with your friend, just arguing with your friend, then very often we end up that okay, either you are right or I am right, not both. And sometimes it so happen that okay, neither you nor me, koi bhi nahi, neither you nor me. So these are the two extremes, you know. One extreme is either or, kind of binary, either 0 or 1, nothing in between that. And another is okay, they are rejecting both the options, neither this nor that. That means they are just leaving the battlefield. They are not no more arguing. They are leaving the argument. My question is, rather my suggestion is, that it's a better way to opt neither this first option nor the second option. So neither you have to reject the extremes, nor to go for either of them, but you can go for a rather a creative oneness of these two extremes. creative oneness. So now I think you have got the point that why this figure is there. So this is a kind of creative oneness. The fellows are of course two different things. They are two extremes as if, but at some point you can merge together. You can have the same feeling, you can have the same opinions, though you differ a lot, but you are ready to appreciate the difference, right? To accept the difference, to acknowledge the difference, and finally to come to a single point without harming anyone else. So that is philosophically very interesting. Now let me go ahead along with Einstein story. So a few more why and why nots you can say on duality that I have already explained actually in the last class. Planck's and Einstein's the same formula. Are they same? So that is one point. Why they same? Why they are not same? Etc. For why and why not. Newton and Einstein. In fact, Newton was also in favor of the light particle concept in a different from a different perspective actually, not in a quantum perspective. And Einstein finally gave the same concept that light is particle. But the question is, are the same? Newton's concept and Einstein's concepts of light particle, are they same? Again, that why same and why not same? Another is that Einstein and de Broglie. Okay. Again, this is very interesting. A simple maths. Okay, from relativity we get that E equal to Pc. P is the momentum and C is the light velocity. So energy of something is its product of momentum and light velocity. And then if it is light, then again from Einstein of the same year paper, this is from relativity and this is from photoelectric effect. So E equal to Pc and E equal to h nu, right? So these two are same, Pc equal to h nu. So if you equate, then you get okay, nu is frequency of wave, and that is always the velocity by the wavelength. Nu is c by lambda, or nu into lambda is always c, that you know. So you replace nu by c by lambda. So what we get, that Pc equal to hc by lambda. So on both sides you cancel c from both sides. So what we get finally, P on your left and h by lambda on your right. And this is I am getting from Einstein's two papers of 1905. But you will immediately jump up and probably will say, sir, this is de Broglie hypothesis, and that came in 1923, long after 1905, after 18 years. So this is de Broglie hypothesis, but I am claiming that this is Einstein hypothesis. So can you explain now that why this so? This is so and why this should not be so? Can I call it a Einstein hypothesis or not? What it's apparently what it looks. Are you agreeing with me that probably as you saw, the way I saw it looks like Einstein's hypothesis? You tell me whether it sounds like that or not. Please, any one of you or two. My calculation, just one line calculation shows that. বলো
স্যার ওয়েভলেন্থ তো লাইটের হয় পার্টিকেলের মোমেন্টাম এইরকম একটা কন্ট্রাডিকশন ছিল
হ্যাঁ but this relation is p equal to h by lambda, that is you must agree that this is from de Broglie relation, isn't it? Of course, number one. Point number two, but this simple relation I have reduced in a single line using two concepts of Einstein. So if this is so, then shouldn't we call it that it is not de Broglie but Einstein hypothesis?
সে তখন বোধহয় দুটোকে একই মেনে নিয়েছিল,
এটা কি
বোধহয়
এটা হবে যে
বল
particle has wave nature and simultaneously wave has particle nature. তো সেটাই তো দুজনে মিলে তো একই জিনিসই মানে প্রুফ করছিলেন যে
হ্যাঁ, তাহলে এই ইকুয়েশনটা তো আইনস্টাইনেরই হয়ে গেল। দুটো প্রমাণ তো হলো একই ইকুয়েশন দিয়ে, তাহলে এটাকে আমি আইনস্টাইন হাইপোথেসিস বলতে পারি। কিন্তু এটাকে তো আমরা ডি ব্রগলি হাইপোথেসিস বলি, যেটা অনেক পরে এসেছিল এবং এর জন্য নোবেল প্রাইজও পেয়েছিলেন। The same equation for what he got a Nobel Prize, de Broglie, actually I have shown you without any error or mistake that this is derivable from Einstein's equations. So should not I call it an Einstein's product? Why we are going for de Broglie? That is my question.
আইনস্টাইনের সময় বোধহয় যে লাইটটাই পার্টিকেলটাই লাইট, ওই জিনিসটা উনি অ্যাকসেপ্ট করেননি, ওয়াই এন্ড হোয়াইট নট যেহেতু বলছেন।
You are on the way, the right track. Actually, it is a question of philosophy, but you have to understand that first of all you have to recognize that yes, it is a question. It is an important question, something to explore, and then if you reveal what the answer comes as, then you will see, okay, it is a very interesting as well as it's a bit philosophical. Now let us try to touch that philosophy, that why it should not be called Einstein hypothesis. It is correctly called de Broglie hypothesis, as we call it. Einstein and de Broglie, are they same or not? Okay. The thing is that, yes, of course, the same equation de Broglie found it. Einstein might have found it much earlier. Einstein might have discovered what much later was discovered by de Broglie, but Einstein could not. Einstein did not, rather, and he could not. My question is why? Philosophically, why?
স্যার ডি ব্রগলির সময় উনি ইলেকট্রন জাতীয় মাইক্রো পার্টিকেলস গুলোকেও কাউন্ট করেছিলেন, তাই স্মল পার্টিকেলস গুলো যে
Yes.
ওয়েভের সাথে অ্যাসোসিয়েট থাকে সেই কারণে।
That is the fact, but it is not the cause. That is the fact. That is the de Broglie hypothesis. But my question is why it didn't strike Einstein. Einstein has already given the equation P equal to h by lambda. Einstein is already giving the duality concept of light particle and wave both. So all the things are given by Einstein, but still it is de Broglie who got the Nobel Prize for the same equation. So it's a very intriguing question, you know. The answer is, number one, of course you have to acknowledge that the equation is the same and it's a concept of duality of wave and particle. Up to this point it's okay. But the second point is even more important, and that is, when Einstein is talking about duality, he is talking about the duality of light and light only. That means light is behaving as particle, though it is basically wave. As if there is an inclination of Einstein to establish something as solid material, solid particle. Even light को भी मत छोड़ना, light wave हो तो क्या, इसको भी particle होना चाहिए. So as if there is a bias of Einstein towards the solid particle something, the solid entity, because the entity is solid, it is something created by God gifted kind of thing. A different kind of God, but God gifted kind of thing. So it has to be there. He is asking no question about the solid particle. He is asking the question to light, which is basically wave, has already been established by Maxwell, and he is asking, okay, light, you are wave, that's fine, but you know you are also the particle. But the reverse journey was not given by Einstein. That means the journey was incomplete. It's a one-way traffic. Einstein could only provide the one of the ways, but the reverse path was given by de Broglie. De Broglie was even more adventurous. He simply put the question that I have no bias. If a wave can be particle, that is light, then why not the other way, that a particle like electron has to be wave? This revolutionary concept that Einstein could not believe, that Einstein could not think of, because his philosophy did not accommodate this kind of thinking, that particle which is solid entity, which is God gifted, it need not be wave. But de Broglie is a young man. He is saying that why not? Why not the other way? As you are talking about light, I am talking about electron. In fact, I am talking about any damn thing. So that is the more generalization part of Einstein. So Einstein was very narrow. Einstein was very specific, whereas de Broglie giving the same idea, but he is more general, he is more broader, and he is encompassing each and everything under this theoretical periphery, that both wave and both particle. So electron, light, you, me, any damn thing is duality. So now I think you got my point, that how revolutionary the concept it is, though mathematically it is so simple. The equation even is exactly the same equation. So I think that gives you a lot of insight into the understanding of your quantum concept, isn't it? Is it clear?
Yes, sir. Yes, sir. Absolutely.
Okay, thank you. And now the questions. This set of questions actually was my question long back, and as I mentioned in the last class that I used to raise these questions in my community to teachers, and always the teachers discouraged me to ask this kind of questions and simply saying that okay, probably Piyutos, you are talking about philosophy, but this is science seminar, so forget about those. But I kept on asking questions, and all on a sudden I really got excited like anything, and I jumped up from my chair. That okay, I was very valid in my framing my questions. The questions are very relevant because the same set of questions were raised by none other than he has recently got a Nobel Prize, Roger Penrose. Roger Penrose, he was writing a foreword for that book. That 5-year that 5 paper I mean, have shown you a few minutes back, and that miraculous and that book that contains the 5 papers of Einstein. Actually, the foreword of that particular book was written by Roger Penrose, and in that foreword he is asking or raising this same set of questions. The first question, that Einstein being a pioneer, leading, founder, but how it happens that he was left behind by his contemporaries. So in the research of quantum, in the thought process of quantum development of quantum mechanics, what happened that Einstein was left behind? Though he is the pioneer, he was the boss, big boss, but somehow he failed to develop any further. And the answer he is saying, not me, but Roger Penrose, he is saying that this is because of his outdated philosophy. So now you see how the question of philosophy is there. Because Einstein philosophy was a bit realistic philosophy. The standpoint was a realist standpoint. The philosophy students know these concepts much better. And because one more important point, that Einstein was a believer of something solid or actual physical reality. Something is there, that means physically by its solid entity it should be there. That was his belief. He couldn't believe of something wavy existence, right? So in this connection, I would again like to link it to the Buddhist philosophy, that Einstein earlier in case of when he is proposing that light behaves as particle also, then he is accepting the middle way type concept, that okay, embracing both, it is there something. But now when it's a question of electron, then he is failing to accept the Buddhist philosophy of the great middle way. So he is not in the Buddha's realm at this time, but earlier he was in the Buddha's realm. Though the rejection made by Einstein was highly accepted by Bohr, by de Broglie, by Heisenberg, by Schrödinger. As you mentioned that there is a different school of thought that was led by Bohr. So there was a very famous debate between Bohr and Einstein. That book I was referring to, centenary volume of Einstein and centenary volume of Bohr. Actually, I got a lot of insights on this topic from both these books. So that's how I like to say in connection to Buddhist philosophy, that makes me easier to understand the things, to grasp the things very easily, and to have a synchronous thought along with Roger Penrose. And moreover, I was a bit satisfied because my questions were validated. Not only validated, my questions were answered in the same spirit and footing as I used to think in terms of Buddhist philosophy. Well, a quantum lotus on a few more, and why nots. So there is another point of debate between, as I mentioned, between Bohr and Einstein. Bohr and Einstein. Einstein, at one point of time, I mentioned earlier that Einstein could not believe the probabilistic interpretation of wave mechanics or wave mechanics. And probabilistic means something like probability, pasha, gambling. So Shokunir Pasha Khela, you know, from Mahabharata. And at one point Einstein is commenting that God doesn't play dice with the universe. That means he actually wants to say that the law which governs the universe, it cannot be probabilistic, it should be deterministic. And Bohr was so bored that he told immediately that please stop telling God what to do. তুমি আর যাই করো বাবু, ঈশ্বরকে বলো না কি করতে হবে আর কি করতে হবে না. So stop telling God what to do, and God doesn't play dice with the universe. That's a very famous quotation actually, very interesting quotation. Similarly, another thing is that Heisenberg and Einstein. Einstein not only that probabilistic concept, but Einstein didn't believe the uncertainty principle either. Actually, they are connected, uncertainty principle and probabilistic concept. So that is also. Now I would like to quote. You see, Einstein on quantum. You just any one of you please unmute yourself and give me a few seconds rest. You please read out the first quotation, any male voice initially. Any male voice, you please read out the first quotation. Go ahead, please.
Sir, this one, quantum mechanics is this first one.
Yeah, quantum mechanics.
এটা কি বলবো?
হ্যাঁ, এই কোটেশনটা পড়তে বলছি।
আচ্ছা, quantum mechanics is very worthy of regard, but an inner voice tells me that this is not yet the right track. The theory yields much, but it hardly brings us closer to the old one's secrets. I, in any case, am convinced that he does not play dice.
Good, thank you. So, as I mentioned, that Einstein even being the pioneer and founder member of the quantum club, he was not very confident about the beliefs and the development of quantum. So that's why he's saying that it is okay, it's working, that's fine, but it is not the last word. Something more yet to come. And later on, we saw in other quotation that he was talking about the hidden symmetry, etc., as a replacement of quantum theories. But till today, we are happy enough that quantum is not replaced by any other thing. Quantum is perfectly okay because it produces the results. The experiments are well explained by quantum mechanics, right? So this is one quotation of Einstein on quantum, and now female voice I would like to see, like to listen to read out the next quotation. Anyone, please?
It is only in quantum theory that Newton's differential method becomes inadequate, and indeed strict causality fails us, but the last word has not yet been said.
Okay, thank you. So the same thing almost echoed, that okay, it is somehow working. It is clear that Newton's differential methods is not enough. We need something else. But it indeed strictly causality fails us. Causality means cause and effect, the deterministic things. It is failure. But he is not again confident. He is saying that this is not the last word. The last word not yet been said. So that is how I am explaining that Einstein had not that much of belief. Okay. So the next, let me read it out. Finally, he is saying that lecturing on quantum theory is not for me. Though I have labored much with it, I have gained little insight into it. So that is very surprising. A man like Einstein is confessing that this is not my cup of tea, though he is the pioneer figure. He has revolutionized the idea, the concept of quantum theory. But he is saying that I have gained little insight into it. Actually, because the philosophy of quantum and the philosophy he used to believe, they are not at par. So it's a more of philosophical battle with himself, not a battle with any other person or any other concept. Well, you see, now this is very important. This is very important. Please listen to me. I am reading it out. Okay, this is Bohr and this is Newton. Now, although wave and particle behavior of an object mutually exclude each other, both are necessary for the full understanding of the object's properties. I call this new situation complementarity. So you see, doesn't it echo the principle of Buddhism, the middle way, great middle way? He is saying that it looks to start with that the two opposite behavior of nature, that is particle and wave nature, it mutually exclude, it seems to be, but it should not exclude. However, they look very different, very opposite to each other to start with, but we can accept both. And clearly he is saying that both are necessary for the full understanding of the object's properties. So when you are in a dilemma regarding any issue, any simple daily life issue, a quarrel, argument between father and mother, starting from that up to the quarrel or argument between two friends, what happens that okay, either you or me, this kind of option we go for, but hardly we can accept this Bohr's complementarity principle. He is saying that why it is not so, that you are correct, I am also correct, and the more correct thing is something different from both of our correctness. That's the third something middle way, isn't it? So that is Niels Bohr is calling this as complementarity principle, right? Unfortunately, this principle or write up on this particular concept is not published or mentioned anywhere else in any other textbook. But in this book, Bohr Centenary Volume, a separate article is there on this complementarity, as saying a complementarity way of life. So there, that author is explaining to start with the scientific things behind this principle, the scientific thought, and then he is claiming that it is much better if I can adopt this principle as a philosophical principle in my life, in my daily life. That is complementarity. Then I will show that how it can resolve so many of social and political and socio-political problems if I go for this kind of beautiful Buddhist principle or a physics principle, you can say, as given by Niels Bohr, the principle of complementarity. Now you see the classical physicist. He is saying, Newton, is very simple logical, that if two descriptions are mutually exclusive, then at least one of them must be wrong. So it looks very simple, that my father and mother are arguing, and of course one of them would be correct and other person would be wrong. Both of them cannot be true at the same time because they are telling opposite things. So I am not concerned who is correct, but logically one is correct, the other one is wrong. That is the classical view. But in the meantime, Gangaয় অনেক জল বয়ে গেছে, quantum develop করে গেছে, the quantum concepts, the uncertainty, the duality, the probabilities, etc., etc. And now we are ready to accept that even though they look opposite, it may be they are very complementary, supplementary, not rival, not contradictory. So that is the beauty of this philosophy, you know. So as a quantum mechanicist, Niels Bohr is what his answers to this Newton proposition, that whether an object behaves as a particle or as a wave depends on your choice of apparatus for looking at it. So whether you will agree to your father or your mother, it actually not an issue. It is the issue that how you look at the problem, how you are using your apparatus. So it is up to you that how you will choose the thing, how your father or your mother, who is more correct or less correct, or it is the question that you are not concerned about their correctness, you want to bring something in between which will satisfy both of them along with you yourself. So that is the beauty of Bohr's complementarity principle. So let me give you a few more words on Newton, Bohr and Einstein Of course, this is very much science and more of philosophy. So I will go ahead along this line if you only allow me. So let me ask you the question that are you getting some insight or interest out of this insightful narration or not? You just tell me yes or no.
Yes, sir.
Yes, sir. One of you. What about others? At least 2 or 3 more?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir.
Thank you. So I am starting again from these 3 great people: Newton, Bohr, and Einstein. Sachin Tendulkar, Brian Lara, and Ricky Ponting. These 3 stars. First, let me start with Tendulkar. Newton. Newton is saying, no, it is from, Einstein. I am not an atheist. Atheist মানে হচ্ছে ওই নাস্তিক, মানে যারা ঈশ্বর বিশ্বাস করেন না। তো আইনস্টাইন বলছেন I am not an atheist. আমি নাস্তিক নই। I do not know if I can define myself as a pantheist. Pantheist মানে যারা সর্বত্রই ঈশ্বরকে খুঁজে পান, ঠিক উল্টোটা, atheist-এর উল্টোটা, ঠিক আছে? Theist তো শুধু না, pantheist. But Einstein is saying that I am neither nor. I am not an atheist, and I am not quite sure whether I can call myself an pantheist either. Right? The problem involved is too vast for our limited minds. So to me, Einstein was actually bypassing the question. Actually, it was an answer to a question. I have given the reference that the question was, do you believe in God? The answer was like this. So kind of bypassing the question actually, that I am neither, I am nor. So a few minutes back I was referring either or, neither nor, isn't it? So now you can link it to this discussion. Well, this is from Einstein, Einstein. Now Newton. Newton, like many of us, he is a strong believer. He was a religious person, unlike Einstein. He simply says that yes, I am a Christian, a special kind of religion I do belong to. So I am neither, I am either or category. That I am a Christian. That means I do believe in this God only, not any other God. So it's a kind of either or, binary, 0 or 1. And Einstein is telling about neither nor, neither this nor that. Einstein is saying yes, I am this, either. But my point is on the complementarity principle, that means Bohr is saying that you can go for neither this either or, that is like Newton, nor like neither nor. So you can reject both either or, neither nor. Rather, you can have a place in between. How? Embracing both of them and transcending both of them. That is the complementarity principle. That is the Buddhist middle way. That I don't need to bother about either accepting either of them. No, neither I am concerned of rejecting both of them. I can accept both of them. I can embrace. Gale mein lag ja. Aao, gale mein lag ja. Embrace, but I am not embracing as such. I am transcending also. দুজনকেই আমি ওয়েলকাম করছি, স্বাগতম বলছি, কিন্তু তাদেরকে অ্যাজ সাচ স্বাগতম বলছি না। তাহলে দুজনের থেকে বেরিয়ে তৃতীয় কোথাও একটা বৃহত্তর জায়গায় চলে যাচ্ছি। That is the complementarity principle. Okay, so more specifically from a scientific point of view, let me read out this quotation from that title that I was referring back a few minutes back. That author was giving an article, Bohr's Complementarity Principle, a Way of Life. Now he is saying that it is possible to grasp one and the same event by 2 distinct modes of interpretation. So it's possible that there are 2 distinct modes of interpretation. These modes are mutually exclusive, adari, opposite, mutually exclusive, but still they also complement each other. So they are not rejectable, even though they are exclusive to start with. Only their juxtaposition bring out the perceptual content fully. So if you are holistic, if you are concerned in the whole of the thing, not parts of the thing, then you can accept the partial truth of different people, different facts, different compartments. But still, you can compile in a very cohesive way, in a very creative way, to get the idea of the whole as is whole, as such, the perceptual content fully. So juxtaposition, that means you have to blend them together. So what you see that seemingly irreconcilable concepts may not be contradictory. Seemingly they are irreconcilable. মা বাবা এমন বাজে কথা বলছে যে দুজনকে একসঙ্গে ভাবাই যায় না, অথচ তারা দিব্যি একই ছাদের নিচে বছরের পর বছর আছে, isn't it? So seemingly irreconcilable concepts, but they are not necessarily contradictory. They can be complementary, right? So reconciliation from seemingly irreconcilable concepts, that is the complementarity principle, and that is the great middle way. In Japanese they call it honmakukyo to. Honmakukyo to, that means consistency from beginning to end. At different layers they seem to be different, but there are a lot of consistency, continuously varying something. They are linked together, they are coupled together, and that is honmakukyo to. So a way of life, Bohr's complementarity principle, a way of life. You see, so what do you see, that contradictory, opposing views may be complementary and eliminating each other. Opposing views, opposing aspects, actually they explain only parts of a totality, and divergent human experiences, actually there are some underlying harmony, and that is your role as an intellectual humanistic person, to find, to search that harmony among the apparently seemingly divergent, opposing, contradictory people, right? That is the Indian tradition, that is the Indian culture. But unfortunately now in today's time we are being taught what Indian tradition is, which is exactly opposite to that what it is really, very unfortunately. So needed in a few cases, like life is not binary, like say apparently opposing or contradictory views are nature versus nurture. Some people say everything is controlled and dictated by gene, right? You have got all your qualities from your parents and chodda purush, that is not nature but nurture. But we are believed also that yes, you have got some qualities from gene, of course, but at the same time I am embracing the other concept as well. I can train you, I can nurture you differently, I can make you victorious over your genetic problems. Tradition versus innovation. Some people will say that tradition is the best thing, but at one point tradition was created, so at that time it was not a tradition, it was made at that moment. So that means they were innovative at that time, and now we are calling it tradition. So we neither neglect tradition nor do we neglect the innovation. Let them be hand in hand, একসাথে চলতে পারে. Individuality versus nationalism, right? So some people say that my personal freedom is important, my freedom of speech is important, so I can condemn anyone because I am free to say whatever I like. This is your extreme individuality. And on the other hand, some people say in the name of nationalism that ek jati, ek bhasha, ek desh, ek pradhan mantri, ekjon sob kichu. So this kind of singularity, not plurality, and that is they are enveloping as nationalism. But that is another extreme as well. So my point is, if you follow the Bohr's principle, if you follow the Buddhist principle, then you can transcend, accept, embrace both individuality and both nationalism, and to emerge as humanism, right? So these are the few concepts, and finally I am talking about physics, not politics, but it looks or sounds like a bit politics. Bohr's complementarity in today's binary India. So most of the time, whatever you debate you are in, if you just see the prime time channels, people sometimes calling it Godi media, whatever it is, but it's very ironical, very disgusting that in any debate, whatever you say, they will immediately label you as you are pro or anti, either 0 or 1. But why I cannot be both? Because I am simply talking about the issue, and that may sometimes favor the pro or the anti. It doesn't matter for me. I am concerned with the issue. But unfortunately, the people like not the Bohr's complementarity principle, but this kind of binary principle. Well, there was a debate, long-standing debate. I think 3 lakh. It should be more than, not 3 lakhs, but I think okay, the number is not exactly important, but it is very important that a huge number of farmers suicide because of they were not being able to repay their debts, and on the other end, government spent 3,000 crore rupees just to erect a statue of Vallabhbhai Patel. So to me, they are just two extremes, and you are choosing either or. Some people will say that there should be no statue in India, only we should be concerned with this kind of thing, farmers issue. And some other people, unfortunately they are majority, that they will say no, we have a tradition of Indian tradition to salute our statue, so we can spend as much money as we like without bothering about our DGP or economic status of farmers' suicide. So both are very extremes. So why don't you be somewhere in between? That's my question. Mandir and masjid. So lot of lives, human lives. You know, life is the most precious gift one can have, and we are just demolishing lives like anything on the street in the name of cow's meat, right? In the name of dharma, in the name of mandir and masjid. But neither Ram nor Rahim, no one wants this kind of killing of human being. But we being human being, we are killing just in the name of mandir and masjid. That means that basically what's wrong? That means we are not being able to follow the Bohr's complementarity principle. We are either opting for either or, that means mandir or masjid. And some people are there who are saying neither mandir nor masjid. My point is, why in 2021 we are not being able, by under suitable leadership, unfortunately don't have that, under suitable leadership, that we can embrace both, we can peacefully, very peacefully coexist along with the Bohr's complementarity principle. Why don't we? Why can't we? So so in between, does it mean that it's an arithmetic mean, just in between 2 points, 2 extremes, x1 and x2? So where is that balance point, right? What is that middle point? So in search of the balance point, okay, individuum, complete freedom, suppose let me call it F for freedom. So you are on this extreme left, say I rely only individual freedom. I'm least concerned about nationalism, my country, my family. I am an individual. That is one extreme freedom kind of thing, F. And on the other hand, the extreme opposite, R, regulation, totalitarian state, orderly. So everything has to be ordered by single dictum. Okay, bhayo or bahino, this is the only regulation, R. So that's the kind of thing, right? So R and F are two contradictory things, and you know there is an uncertainty, delta F and delta R. So freedom, you have to put some uncertainty over there, and some regulation, that is also uncertain. You cannot be 100% accurately regular. You can't be. There is some uncertainty. But what is that political constant P? In physics, it is h bar by 2. But if I frame such an uncertainty principle in our socio-political scenario, then what is that political constant P? Okay, we have got a lot from physics. Atom bomb, we have got physics from physics. Then why not something of humanity from physics? That means Bohr's complementarity principle. But the thing is that it is very difficult to say what that middle point is. We are still in search of. Every time we do conduct election, every time we do vote, every time we choose our leaders, hopefully this time our leaders will lead to the right way, but unfortunately till today it's worsening even more. We have not been able to find that $1 million P, the point. So only time wait until a new revolution another annus mirabilis. Annus mirabilis is that miraculous year, Einstein's 1905. So probably we have to wait for another annus mirabilis, revolutionary year, where we will get some revolutionary ideas. Maybe some second Gandhi will come up or something like that. And till then, we have to wait and we have to say goodbye. So that's all so far from today's lecture. Thank you for your patient hearing. Now you are free to ask questions or comments. You are free. Not only I will suggest you, I will encourage you to make comments, because it's not a simple usual lecture. Of course, it is science, but I have told a lot many other things. So how did you like it? How it reveals, whether it reveals at all something or not, that you have to make some impressions. Please go ahead. Thank you very much.